What happens when we create artificial neural networks that emulate our own brains, but operate with the logic of ones and zeros, and then scale them up to a colossal level? It's no longer a hypothesis. It's a reality. Emergent properties have appeared in artificial intelligence models that have surprised, puzzled, and even amazed their own creators. In a neural network, especially in transformers, the rules are incredibly simple: mathematical operations, multiplying matrices, adding numbers, and applying functions that determine which words are more important in a sentence. The architecture, the set of rules, was designed. They were given a goal: to predict the next word. And then they were fed an almost inconceivable amount of data, a large part of all digitized human knowledge. And then, when the models reached a colossal scale, with billions of parameters and trained on trillions of words, emergence appeared once again, unexpectedly. One of the first emergent abilities was something called in-context learning. If we told the model, cow is yes, car is no, chicken is yes, and then asked about pig, it wouldn't search a database. It reasoned that a pig is more like a cow than a car, and answered yes. It inferred the pattern without anyone explaining the rules. Another surprising ability was step-by-step reasoning. In 2022, researchers at Google discovered that if they gave a model that failed at complex problems the simple instruction, think step by step, its success rate skyrocketed. The model learned to reason out loud, breaking down the problem and arriving at the correct solution. No one taught it to do that. Then came something even stranger: zero-shot translation. An AI trained to translate from English to French and from English to Chinese suddenly could translate directly from French to Chinese, even though it had never seen that language pair. This suggests it wasn't just translating words, but had built some internal representation of meaning. And in some cases, it went even deeper, building internal models of the world. When training an AI to play Othello just by showing it moves, scientists discovered that, in order to predict the next move, the AI had built an internal representation of the board. It didn't memorize sequences, it inferred the rules of the game. But perhaps the most astonishing emergent property is functional code generation. Trained to predict the next token, the expectation was that it could complete lines of code. What emerged was the ability to write entire functional programs from scratch, debug them, explain what they do, and even translate code from one language to another. This goes beyond imitation. It's an emergent understanding of logic, syntax, and structure. Reasoning, translation, internal models, all of that is fascinating. But functional code generation is the acid test. Code isn't subjective. It either works or it doesn't. The fact that an AI can generate something with strict internal logic that produces a working result may be the most compelling demonstration of emergent understanding, far beyond being mere stochastic parrots. The great lesson of modern AI is the same as that of Conway's Game of Life. Scaling up massively doesn't just give us a slightly better version of what we had. Qualitatively new and surprising capabilities emerge, ones that were never explicitly designed. Scientists are no longer just engineers building machines piece by piece. They become gardeners. The seed is the architecture, the fertile soil is the data, and they watch in awe at what kind of wondrous plant emerges.